Hello. Yeah, I think we are live, and we continue working on what? The same topic, or we pause on it. It's up to
Well,
you.
Uh,
first, hello, everyone.
Yeah, yeah,
Welcome to
yeah.
another
Hi.
session of hacking and
It's
vibe hacking.
yeah. Hello, everyone. Actually, it's my
Uh,
fault. Hi, Andrey. Hi, Kirk. Hi, everyone.
Hello. Yeah. I have two ideas that I would like to propose. First, to go on with B-trees and merging B-trees. I did some progress offline, and I currently I need input. I need ideas. I don't know what to do next. Another is I need to write a test for. Like we found data corruption in not yet released Postgres 18. We fixed it by reverting very important patch, and we want this patch back in 19. That's why I need better test, and we can work on that test.
Because we
Uh,
have time until 19, right? It's like next
uh,
year.
yes, kind of. I agree that like the same applies to B3, I think. We cannot merge B3 in Postgres 18 anyhow.
Right, but since we've been talking about the B tree stuff, let's at least make a few comments about what happened in the hackers group. Okay, so Andrey posted a work in progress post to the hackers group with the code attached and our ideas on this kind of merging, and we had a couple good responses come back. And listen, even a response that attacks your position is a good response if it's well thought out. Okay, that's my view on these things. This is about learning. So one of the ones was, I think it's Peter. Is it Gregorian? Is that how you say his last name? It's
Uh, like Reagan, but Gagan.
Oh, Gagan, Peter Gagan. Thank you. So yeah, I might get his name wrong. My apologies, Peter. Anyways, Peter has a lot of good experience in these areas, and and I respect him from so many of his other posts. One of the things he brought up was, "Is this true?" And he referenced two other published papers. One published in ACM, I believe it was, and the point of these papers were the way that we're deleting in Postgres is delete empty. And the other way of handling this is called merge half empty to get rid of empty pages. And the merge half empty, when they did the comparison, was less efficient overall, right, than the waiting until the pages were completely deletable. Now, I don't know exactly how much less efficient, but the reality is that yes, you're going to need more locks if you're overly aggressively merging pages. And my challenge was merging a half empty page is kind of way more than I was looking for us to do. I was looking for us to nudge a 90 or 80% empty page into emptiness and move forward for the same reasons his article explained. You lose efficiency because you affect more reads by constantly merging. And you also run into issues where a recent page split triggers the half merge into the other page. And that becomes just thrashing a little bit. So it was well thought out stuff that he gave us to read on the topic. And I think that stuff is really important. Um, anyways, for us to pay attention to. But the key takeaway, and then I'll turn the floor over. His answer too was, "I hope you guys bring some benchmarks." And his answer is, basically, and this is interesting, but it gets back to what's the definition of bloat. It's not just free space; it's free space that has a noticeable impact that you're willing to do something to get rid of. And I think it's a reasonable request. So we should have some kind of idea to create bloat, show that it affects performance, and then show that our fix reduces that performance impact without a secondary negative perform. All reads are 90% slower, but whatever. We want to make sure that kind of thing. Anyway, so that was kind of my introduction back into this topic, I was kind of interested to see what our take was on this because we haven't met since all of this feedback came out. So, Andrey?
Yeah, so I replied to Peter that with screenshots from my production servers that I kind of have some indexes that are basically secondary indexes on a table with a key data. And we have a daily repack that is reducing its bloat by factor of 20 or so. So the bloat is more than 95%. And there are a lot of non-empty but almost empty pages. But I cannot experiment with my production. I cannot run so we ended previous session at an almost working version of page merge. What I did offline was I just fixed critical sections, somewhat fixed, not perfect, but made a whole login of merges, and that's it. It was working, and that's what I posted. But I'm afraid to use it in production. No chance to use it on 1 terabyte database right now. But if we can design a workload that proves that this is usable technique, but we need some kind of artificial workload. Maybe we can ask LLM to do so.
Well, so a couple things on here. You're pointing out, and every chart is good to a degree, but some need 1,000 words of explanation to make sure we're on the same page, right? So I see that you have nice, growth on the sizes, but what we don't have is we don't have feedback on speed. Or is there speed somewhere in here that I'm not seeing? Because I see no marks of timing, right? So I don't see what the negative impact is other than disk usage, right? From a performance standpoint, we know it's going to be a little bit slower if you're reading mostly empty pages. Everybody should, but we should be able to exemplify that. So we should be able to create a similar structure in a test database, 90% deletion, but a large enough table set that it needs to read hundreds of pages, right? 8K pages out to make sure it answers the query to see, do we see the performance increase when we fix this challenge, or is it going to be hidden by the
We
disk cache?
discussed
Go
this.
ahead.
We discussed this before. In my opinion, performance
We
has
discussed
many.
it theoretically. What we want a practical
I
proof.
shared practical. Well, practical proof is a good idea, but I discussed it not theoretically. I see it, and yeah, examples we need, yeah, for sure. So we discussed what we discussed.
Sorry.
Performance is a multi-dimensional thing. One thing is just lookup time. I think it's not number one problem. This is my strong position after many years of observation of practical examples. Number one problem is the word thrashing I like, by the way. So how we pollute buffer pool and the page cache, and how we create more full page writes in wall, this kind of thing. So if index is 99% bloated, we have much worse buffer hit read ratio. It cannot be checked if index fully fits, right? We need to see the picture as a whole, not only this index. If some index, big index is bloated, some other pages, maybe some tables will need to be evicted to deal with pages we need to load. Sometimes it's lookup performance as well. If data is sparsely stored, like to fetch our 100 or 1,000 tuples, we need 100 or 1,000 buffers at least, versus if it's compact storage and many tuples are present inside one page. But it might happen not only with bloat, by the way. But my idea is such index becomes huge. It pollutes caches, evicts very useful pages we need there. We could have them. Auto vacuum to process this index takes more time for it to traverse it, right? And every update or any write which changes the index for each page, we need a full page write after checkpoint. The more pages we have, the more full page writes we need to update logically with the same data, like 1,000 rows we need to update, right? How many full page
Let's
writes?
simplify, not like too many factors. Like I completely agree that like it's a multidimensional problem. Like performance is a set of many parameters.
Aspects, yeah.
But can we somehow say that like we are measuring one parameter and it becomes
Buffers.
better?
Buffers.
Shared
How many
buffers.
buffers to read 100 rows or to change them? Because buffers and pages, if we think in that, not about seconds of lookup. If we think about how many buffers we need to
Can we
read or
measure
write,
how many buffers are in shared buffers for given relation?
yeah, PG buffer cache extension helps to understand the current situation.
So we can design a test that is creating a polluted index with some workload
For
and
me, yeah, for me,
measure size of this index, average size of this index
this is
during the test.
so to create micro tests and speak about macro level of metrics will be hard. We need to design whole database or understand how it will behave. For me, if we say like this operation now costs 100 times more in terms of IO, it's already a big deal.
I think you just nailed it. I think the answer really is just focus on the IO. Focus
Yes.
on the size and the IO. Because if we do that, all other things being equal, if you significantly reduce IO, you always get a performance increase,
Yes.
right? If you significantly increase your IO, like if you increase how much IO you're doing, that impacts every part of the system. IO is fundamentally limited.
Yeah, this can be checked at micro level. We just explain analyze buffer settings, variables, right? And to go to macro level, there are two ways there from there. One way is we say IO buffer numbers directly affect timing if we think about cold cases. Because if you think about hot cases when everything is cached, it will be, we need a lot of data to see the difference. And so cold cases will suffer 100% if we need 100 times more buffers to read. And the second path is to go from micro level to macro level. We say, okay, we need just to keep all those buffers in page cache if this index is actively changing or being read.
I want to note one thing. There are, in my view, there are currently two directions of work in this topic. And first is like benchmarks. Peter asked for benchmarks, and at some point we will have to provide it. And there are other problems that Peter outlined, is like
benchmarks of what? I don't understand. So if we have, benchmarks of what? Imagine
let's leave
shared
benchmarks
buffers.
aside. We will think more about them.
No. Let's have 1 gigabyte shared buffers. Okay, 1 gigabyte. And let's have index which is half of gigabyte. It's fully cached, everything is fast. Now it's bloated 99%.
And we get IO. Yes, that's exactly what we will show, but with much smaller.
But it's obvious, but okay, let's show it. Okay. Let's compare cold and hot, like hits and reads. Let's compare it.
Yes.
And I think on the theoretical side, one of the other answers we have to get to, by the way, is he's comparing two very distinct concepts: delete when empty and the merge half full. And my opinion is merge half full is overly aggressive. And if we can show that we can switch it to merge at 20% or whatever, and that's where we're going to cut our threshold, we can automatically start proving that this is on the orders of magnitude more efficient than merging half full. Okay. Half full is wildly available. Okay. So go ahead.
During those 2 weeks since our last call and this discussion, what was bothering me, Peter Gagan worked on deduplication, right? So what was bothering me? If we take typical workloads, like most like unfortunate ones, like Q-like, we insert something, update it a few times, and delete. Deduplication should help a lot, but other cases where we in practice, in reality, end up having like 25% of page filled and 75% is empty in most cases. Like, is it happening with Postgres 14 and newer?
Oh, like deduplication helps many secondary indexes. When you have attributes with a low cardinality, if you have high cardinality secondary index on a queue, it gets bloated. Whatever you do, you just need high cardinality, and the duplication doesn't help in this case. So
in this case, we can have
yeah,
some
it's
cases.
not super frequent case. And by the way, we keep telling folks that like don't do queues on Postgres.
Do queues on
If I'm not
Postgres,
wrong.
just do it properly.
And what's properly?
Go to Cloud SQL, Google Cloud SQL. It has old PGQ developed at Skype 20 years ago, and they maintain it in managed fashion. PGQ is great still. So.
Okay, so if you have a queue, it's relatively easy to get a very bloated index. Maybe there are other patterns. By the way, this this chart shows that there are many big indexes in database, and only one index in both databases is effectively reduced by repack. So each database has just one queue. That's why they have just one instance where we can help. And here, for example, like the bloat is on a scale of 20 gigabytes of 1 terabyte of a bloat. So we can help only in edge cases, but that edge cases create pressure on the database. In this case, it's more important here, 20 gigabytes out of 200 gigabytes. It's not every index, just some of them.
Right. I would like to add two other comments. In reading those papers Peter mentioned, the thing I noticed too was their base assumption. And they have a base assumption of regular data usage and continuous growth. And that's another reason to not merge half full pages. If you have a database that on average is always growing in size or table, then your index is always growing in size, and a half empty page is incredibly useful. The problem we really have is an 80% empty page or 75% empty page is not nearly as useful. Okay. And so this gets back to this same argument in defense of us. So as always, every improvement you make has a set of assumptions working around it. And we know this one has a hot issue related to queues because of the update, right? Because of how you end up doing the updates and how much bloat it leaves behind in the process. Okay, so with that said, if you were to clean this up and make it part of the regular cleanup so that it constrained the bloat much better, okay, even like you're showing on here, the difference is 20 gigabytes maybe, or something in a magnitude of 10 gigabytes. The reality is that once this fixes it, that pattern goes away. But I do agree, there's probably a few other patterns that are maybe not as related to a continuously growing table, where you still, maybe you only get 5% benefit out of it. But all of a sudden, what would happen if I could reduce the number of buffers required across all of my indexes by just 5%? Okay.
Well,
How many more buffers how many more indexes could be completely loaded into memory?
and also
Because
disk
that's what you're doing. You're
storage.
taking that pressure off over, what'd you say? Not that much?
Also disk storage. Also again wall amounts
Wall
generated.
rights?
Yeah.
Right. Yeah. Sometimes some of these savings at the edges are when you multiply the edge improvement. Like the big improvement, you're right. It affects a minor number of tables. But for the ones that
Indexes.
aren't growing, for number of indexes, it reduces that. But for all the other ones, a small improvement times the entire size of your database is a much bigger improvement.
By the way, I was wrong. Cloud SQL doesn't have PGQ, so nobody should implement a queue in Postgres. I'm joking. They have PL proxy. I confused also from Skype. There's
Okay.
another thing I would recommend, River from Brandur. So River is written Go, fast, robust queue for Postgres. Yeah, there are many attempts to do it.
I want to slightly shift our attention to another thing that Peter and Matthias both noted out, that our approach won't work from looking and consistency perspective. And because they said so, I implemented a test. Like I vibe hacked a test that is doing basically two scans. Where are the scans are? Just a moment. Here is a forward scan that is doing order by some primary key, order by some B3, and backward scan that is doing order by some key descending. And when they are running, I'm pausing them with injection points in the middle of a tree that is wholly collapsed, merged to the right. So there, when they have paused on injection points, I'm running vacuum, which is collapsing this tree to the right, and then counting the results, counting how much tuples were found by forward and backward scans. And funny thing,
They're not equal.
yes, they are not just not equal, they are incorrect in different directions. Like for forward scan, we get 1.5, like 50% more tuples that we would like to see. And for backward scan, we missed tuples.
Is it a bug? You mean found bug?
This is
Hold
a
on.
fundamental problem. This is a locking problem.
So this could actually
It's a
have
bug.
a couple different causes. Yeah, it's part of the locking problem they're talking about, but also keep in mind that the compressed deduplication of the nodes, where they store in the actual data the set of records or rows that they point to, right? They have the tuple pointers to block number and then tuple, where the record is, which record number. That is an array of things. So if you skip 2 items in a leaf page, you could be skipping 200 items on disk.
Not in this
You're
case.
not in this case, though. Okay, good.
This is very simple index. I have 250 rows there, and I would expect forward scan and backward scan find exactly each tuple only once, and they do not.
Now, when you do that, can you do a page inspect on the index for me? Because I want to see if you have all unique values, okay, on the index, then I would agree with you. But if there's any replicated values, I think you're gonna miss them in blocks.
Yes, I miss them in blocks. Sorry, do you want to see the results of this scan, or?
I want to see the results of I want to see the index before you end up vacuuming it to see what potentially is going to, so I can explain what's going to be unlinked from their views
I mean,
to see if the record count adds up.
I can't just draw it with a pen.
Oh, okay. Well, page inspect, the upside of doing page inspect is it'll actually show us how many records. right?
I can do page inspecting within a test. I mean, I can, but it would
Oh, no, yeah,
take.
yeah. I didn't expect you to do it inside the test. Yeah, I thought we'd create the index that you were doing and then just page inspect
Uh,
to see the
this
structure.
the thing is like index is in a correct form, but our modifications can have a race condition with the queries
Right.
when they're running. If they're stopped in exactly specific place, we can create a race condition that results in this problem. Let me, I'm not sure it will be visible, but I will try. So we have index like, I designed this index to be like this.
And
So
for the record, this is why I was thinking, oh, yeah, it didn't show it.
yeah,
You might,
The switch off.
yeah, I will. Uh,
yeah, there you go. You
like
turned off your
this.
background. Now it'll do
So
it.
is it visible?
Yeah,
So we have one root page and many leaf pages.
yeah.
And we have two scans that are stopped in the middle. One before page number 20, both before stepping to page number 20.
The one that's about to go away.
They all are going to go away.
Oh.
Every page will be merged to rightmost page.
Ooh.
So both scans have no means to continue. They cannot find the way because they are in the middle of a chain of all deleted pages.
Right.
And in this case, we have nothing to do to recover them, actually.
So this,
So
now that you're looking at this, I want you to think about why my version created a brand new page to merge the records into. By creating a new page to put all the records into, I can let them complete the scanning on all those old pages. And then just when we finish our link to eliminate those at the two ends, all of a sudden, those pages are no longer used, but their scans will complete. And then when our update completes, all future scans will read our links, and the portion that they were looking at just won't be active anymore. And then those can be marked half deleted or whatever that process is. That's
that
exactly why I came up with doing it in the page merge.
I tried to propose it to LLM, and LLM told me that like you don't have to copy somewhere. You can just leave. So essentially, just a little bit more marks.
Oh, no, good.
All these pages will be deleted.
Eventually, yeah.
And eventually, and they are not used to store anything anymore. So I can just leave all tuples right there. I have almost 8 kilobytes of spare memory, which can be used to store anything. And LLM suggested me to just leave tuples on pages. Just don't delete them. Mark page as deleted.
Half
If
deleted,
the
yeah.
scan
Yeah.
if the scan needs it, let it read it.
Yeah.
But the problem there is it doesn't help forward scan. Problem of forward scan is that it had read half of a tree already, returned it to select query.
Yeah.
Then it waits on injection point. This half of data is moved to rightmost page, and the scan finds it again, and we
That's,
cannot deduplicate data.
hold on. I want you to make a box underneath all of your boxes. Make one box underneath all of your boxes for me. That's the new page that we put all of the records onto. Okay. And this is going to be the magic. Once you put that box, I then want you to update the two pointers that come in and out of that box. Oh, I wanted it on the bottom. Oh, did you cut those in half? Is that what you did with those pages?
No, I just draw a small rectangle.
Oh, okay. I didn't see the small. Yeah, you drew it where the lines were. I was expecting it way below the thing, but that's okay. My point was, if you draw one that looks symmetrical to the head as a footer real quick, and then you then update the links to the two endpoints for all the nodes that it's replacing. And you don't touch the inner links from left to right. You only touch the leftmost node that gets updated and the rightmost node that gets updated. If you do it that way, my hallucination is that anybody who's currently reading any of those pages will complete reading the pages and they will never get to our new page. Anyone reading backwards won't get to our new page, but then our new page will have all of those records in it combined as a new page. And then when we finish the update, only new queries will see that path and no queries will see the previous path.
You propose to copy even not deleted page 2.
Right. Not copy. Yeah. So effectively, I'm making a whole new version of all the pages that I'm merging together into one page. I'm making one page that holds all of that data. So wherever you draw those two lines, those two will stay there, but the things that point to them will now point down to our new page. And then the 2 page, right? And then they'll point backwards to those 2 pages that stay behind. And that will make it impossible for these guys, when they already read the pages, once they get on that track, it's a train track to me. Once they're on that train track, it's a different train track. And then they'll skip our page if they keep going to the end of the file in either direction. And then our page will sit there ready to link in. Right? And then once we commit our changes, then all of a sudden nobody will see that old train track of all those pages. And it makes it impossible to duplicate read.
This page is not part of B3 yet, right?
Right. We put everything in our page first. And then this way, anything that wants to finish finishes. And then when we link it into the B tree, anybody who follows our link to our new page automatically routes around all the old versions. And that's why you had to unlink. That's why you couldn't put it in the future page. By merging the deleted ones into an active page, that's what breaks it. Merge all of it into a new page and route completely around the problem, just like a detour on a road. And now anybody who's currently on the road is able to get out in either direction, okay, and then keep going. And they'll never see our detour. But anyone who came after we put the detour signs up sees our pages. And then we can make sure those are all marked half deleted. And then the vacuum process can pick those up because nobody can see them anymore. They're no longer in the linked list.
So basically, we need to copy on write every page that we touched. Even if we touched just a pointer to another.
We only need to worry about the one page before our changes start. Right? And that's it. We don't need the whole page. We only need to know that page because we're going to change its pointer to the right. So it points to us. And then on the far right side, the pointer to the left, that points to us. And then you should be able to see it. Can you make that big box like you have for the title page? Make a big box underneath for the third row, a big box in the middle. Okay, just like your head box, make a big box on the bottom. Perfect. Good. Now,
Sure.
Yeah, there it is. Yep, got it. Now I see it. Okay, so now if you put parentheses around all the pages you compressed, okay, in your diagram, just draw the thing around so you have endpoints around all the pages that are compressed, the ones that contain the data we're compressing. Yeah, that's what I mean. Yeah, one in from what you're doing. Yes, like that. Same thing on the left. So what happens is we have the normal part of the tree, okay, and we have to assume at some point we're not compressing, like I purposely threw out compressing the very first page. I just threw that out as a tough edge case to handle, okay? So this way you can see that it works. I don't want to compress the first page and the last page of the entire tree. That makes it so you have no control. So if I move them in one page, put the parentheses there, now I have this set of data I can flow into a new replacement block. And then all I have to do is link that one up and then link these two back down to mine. And this middle section in your parentheses just disappeared. It logically doesn't exist.
Look, if all our tuples are in now in the rightmost page,
I didn't put
and
them in the rightmost, right? Good, but go ahead.
we had to create a copy of this rightmost page. Like there are some old tuples and some new tuples. We have a new version of rightmost tuple or rightmost page, new version with new tuples and old tuples, and old version of the same page with just old tuples for forward scans that might be
Still
reading
running.
through this race condition. Which one is referenced from parent page? For new scans, we have to reference new version. For any running scans, we have to descend in the same case to old version. So we must create a copy of a parent page too, if we modify something. And this logic will force us to go up to the root. And if I'm not wrong, this concept is called multi-version B-trees. I didn't study it very good, but it exists, and it creates a version of B-tree on any modification, and then merges many modifications together. It's high concurrent, but it creates slightly more I/O, and I doubt that I need to read about it more, about multi-version B-trees. I do not remember this concept.
What if we keep only old reference from parent to child, and then we just swap it?
Propose very simple idea that I proposed already and implemented in list.
Okay.
This is just abort the
I'm just a silly question. Why keeping just one reference and then swapping it with some lock? Is it bad, like for concurrent work? I mean, just
it's hard to limit the scope of modification. You always have to modify upper pages too.
Why?
Because they point down into the tree, into the leaf pages.
Yeah, this I understand. But why do we need to keep both pages referenced?
Are you asking me or Andrey?
Andrey mostly. Like,
good. Yeah.
If we keep references to old pages and then when a new page is ready, only then we swap. What's the downside of it?
That's my goal.
When everything is ready, then swap.
So for new searches, we have to point to new version.
Why?
Because new tuples that were moved from old
new tuples
pages, they should be found.
While we work, new tuples might be created, right? They should go to new location because
even
if they go
the tuple that we moved from old pages,
but we don't move, we just copy.
Yeah, but it's technically a move. It's a copy, but you're right. It's a copy.
Yeah, no, I think new tuples are a problem because where to write them while we're working.
This is a symmetrical problem that is hard to like design in a 1 hour hacking session. But I've proposed very simple things that let's just abort a scan that is encountered moved tuples. Just like cancel this query entirely. What do you think?
Cancel a query. Who restarts it?
User had to.
Sounds not good to me.
Yeah.
But it's very rare condition. It's
really?
It's very infrequent. Like I mean, you have read the reference to a page that was deleted just before you read it, and then you read the page, and there is written like tuples from this page are gone somewhere. Maybe in front of you, maybe backwards, and you don't know where. And you don't know how to find a way back. Like you can try.
Wait. If we talk about aborts, then it means that you can recognize such situation, right?
Yeah, absolutely.
If you
If
can
you never
recognize,
encounter a
why
page
cannot
with
we
moved
restart?
tuples,
Why cannot we restart this scan?
Okay, I let me gel with what you're saying a little bit. Instead of pushing back, let me improv a little bit here. So your concept that you're thinking and trying to combine what Nikolai's thought is, your concept is, hey, if we're currently scanning this and then we pick up a page that we flagged that, hey, we're mucking around with this data, okay? We're moving things around. You're in a questionable mode or a questionable state right now, and dupes could happen, okay? So
or missing tuples.
or missing tuples could happen, right? So some kind of issues could happen. Be on alert. Now, your first suggestion is the easy, obvious one. Just abort and say, "Oh, I was trying to read something was changing. Oracle's mutating table error," and it just throws up its arms. But if I think where Nick was going with this is if we can detect it, okay, and we know what the pattern looks like, the resulting pattern is that a bunch of these blocks linked in together are now going to be all kind of questionable if I'm moving in the forward direction. And now I can get to all of these things on the right hand side because it's going to go to the rightmost page. So I can kind of advance myself to the end of this problem by looking at that flag on every header and saying, yeah, this is questionable and I'm heading in the correct direction. Boom, 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 boom.
I have another
Now,
idea. Yeah, okay.
right now, on the other side of it, you have the answer where it just got moved to the rightmost page. This guy has skipped over and processed that page already. And now he's working backwards. What if he looks at that data and says, because I'm doing a backwards scan, I can ignore that and actually process these rows?
We can recover partially in some cases and reduce number of aborts. But when you find yourself like you're following a right link from a page, you completely have no pin of a previous page. You left it and moved forward, and now you find yourself in a like forest of deleted pages. Some unknown page forward, some unknown page backward. And you can't get back to because there are concurrent splits and merges, and you have no control over it.
You can restart the whole index scan, right?
Yes, you have to restart from the very beginning. But there are many, many cases when you can recover. For example, you are in a forward scan, you found a deleted page, follow it right link, and follow. Hey, here is a backward link to deleted page that I just visited. Okay, anything that I want is just right here. No worries. So I in my test I emulated very bad situation when you're dropped amidst of a new tree that is completely different. But if the tree changes slightly, you can recover from it. But if you have a series of destroying,
during this work of merging, we also could track all the pages which we are working on in some memory space. Maybe it would help. It's just temporary, like we track them and we know what's happening.
Yes, but interaction between Postgres backends is like complicated to code. I would avoid it. Like if it's necessary for parallelism, okay, let's do it. But let's stick with locked for such. But there is a kind of this implementation. We can restrict what vacuum is doing, like forbidden doing unrecoverable deletes. Like never delete one more page in a row. So no scan will find itself in unrecoverable error. So we know that we can recover a scan from single merged page. If we never do then one merge in a sequence of pages.
So if we only ever merge once, okay, meaning we approach a page that's 80% empty and we know we have enough room in the very next page to move it. Your argument is don't do that recursively. Just do it for that one page. And now, and we complete that and then we move on. The next page we look at, we're going to skip over that page now, go to the next one after that page, and we can start this process again. And the reason we can get away with that is a couple fold. One, the number of times we're going to catch someone who's reading exactly our page that needs to be confused and recover is going to be small, but at the same time, they can calculate the recovery. Okay, insofar as kind of like how they calculate that the page was split on them since they started. When they first read, they kept a right-hand pointer and the highest key value. When the page gets split, the first thing that happens is on the page they read, the high key value changes and the pointer to the next page changes. Okay, so they can have the pointer to the previous page in memory, but at the same time, right, they might not see that transaction because transaction ID. But if they have it and they process it forward, then they'll skip over that page and then they'll keep processing on. So they'll read what they were reading, their old version is good, and then they skip over whatever we do and read the next. But in the case of them detecting that we're mucking with this, we're going to do it in almost a similar way. We're going to leave a flag so they know, hey, something's changed, and then they can kind of recover. Interesting. Yeah, this is definitely something that needs this needs about 4 to 6 hours at a bar, you know, with a few people, some paper, a whiteboard, some vodka, you know, maybe tequila, tea. Yeah, I don't know what's the correct wine that goes with an index. I think it's a white wine because it's a dry topic. So
the thing is, like race conditions still persist because, like, a good race condition when something very strange happens. And in this case, if we in one vacuum we say that like never merge more than one page at once. Like, so you have many sparse pages. You do like this merge, this node, this merge, this node, this merge, this node, this merge, this node. Okay, vacuum completed. We are going on with a half a tree, like half smaller bloated tree. But the scan keeps heading. It's still waiting for problems. And the next vacuum kicks in and it's removing. Removing, not removing, removing, not removing, removing, not removing. Again, half merged tree. But the scan is still keeps waiting. And the next vacuum kicks in. And it's merges, not merges, merges, not merges, merges. And finally, our scan wakes up and finds itself in the middle of nowhere and cannot recover. So even if we make like one vacuum, it's never doing unrecoverable changes to scans. 2 vacuums still can destroy a scan. 3 vacuum, if scan is waiting enough, like operating system can stop any process for infinite time. 3 vacuums will definitely kill some scan if it's
yeah, well, we already have a secondary condition of inserts and deletes by some of the other actors. And that becomes the part where even with my third-party page, create a spare page, load everything into it, and then do a quick relink. that gets thrown out the window the minute any one of those scans that worked in the middle of those pages, and its job was to do updates. And it updated some of the middle pages while after we copied them. Okay, it then applied an update or delete.
Something.
Oh,
There was some problem with the sound.
I apologize. My phone rang. So it stole my headset. When my phone goes, it makes the priority.
Guys, I actually need to
Yeah.
Everyone
end
needs
soon.
to go. Yeah.
Yeah, and so today we just asked questions. We have like 3 problems. Benchmarks, log correctness, and something else. I don't remember what.
Oh, well, we have the problem with no matter what solution, we have the old tree, new tree problem, and we still have an update insert problem that we never even considered in this first pass of combining these rows. How do we block to make sure nobody can update anything in the at least two pages that we're playing with? Kind of thing. But we still have the issue of reading in both directions while this is happening, and any updates that might happen. So suddenly I'm starting to think there might be a reason Postgres didn't solve this for 20 years.
Probably.
On this note, it's a good time to pause here and think in background again. Thank you so much.
Thanks, guys. Great stuff.
Guys.
Bye bye.
Yeah, let's think in the week and get back to it.